Welcome dear students. In today's video we are going to learn about Euclid's Division Lemma, the thing that we used to solve the word problems of real numbers, right? Now what does it state? It states any number can be written in the form of a, which is equal to pq plus r, where r should lie between p and 0, right? Now what are the type of questions that you might see? That it said, example 1, show that square of a number is of the form of 3m or 3m plus 1, or show that 6m plus 1, 6m plus 3 and 6m plus 5 will be odd. Now whenever you see these questions, you don't know where to start, right? So let's see if we can take it, we can use the Euclid's Division Lemma in showing or proving these questions. So what we will be doing is, we will be writing it as, let's say if I want to solve the first one, show that the square of a number. So here they need a square of a number. I don't know which number they are talking about. So first of all, let's verify the question. What does the question means? Question means a square of a number is represented by 3m or 3m plus 1. Now let's just list down some of the squares. So it's 1, it's 4, it's 9, it's 16, it's 25, 100 and so on. So these are the few of the squares that we have, or in fact 144 or other numbers. Now if I want to break them in the form of 3m or 3m plus 1, so I will say that this is of the form of 3m plus 1. If I take m as 0, the number will be 1. This will be also of the form of 3m plus 1, 3 into 1 plus 1, so this will be 3m plus 1. Now this is of the form of 3m, if I take 3 as 3, so it will be 3m. This is of the form of 3m plus 1, because I will take it as 3 into 5 plus 1. This will also be of the form of 3m plus 1, where I will take it as 8 plus 1, right? This will also be of the form of 3m plus 1, so I can say 3 into 33 plus 1, this will be 99, 99 plus 1 and so on. So hence you will see various numbers which are square and they are either of the form of 3m or of the form of 3m plus 1. Now how you are going to prove it? You just can't list down the numbers and say that, sir, this is 3m, 3m plus 1 or 3m or 3m plus 1. So this is how you will understand the question, but this is not a proof. So to prove this, we have to use Euclid's Division Lemma. In this, again they say any number can be written in a one particular form. So this is what we have already learned, that p of x is g of x into q of x plus r of x. These are the questions which actually troubles, and this is a very important question from the examination point of view, right? So again, if I am writing, let's say I am dividing number 11 by 5, so this should be 2, this should be 10 and the remainder is 1. So I can write 11 can be written as 5 into 2 plus 1. So any number can be written in these forms, in which this will be the number that you are dividing, this is the divisor, this is the question, and this is the remainder, right? We have discussed it previously in the previous videos, because the same concept is used to find the HCF, but that is known as algorithm, that is not lemma. Now let's come back to the question and we'll try to prove it. The square of a number is of the form of 3m, 3m plus 1 or 3m, right? So I must think that you have understood the question. So let's say any number can be written in the form of q plus r, right? So where r can have the possible values as 0, 1 and 2. So how did this came? I'll divide 3, taking the quotient as 1, number can be 1, number can be 2 and number can be 3. So if I am dividing it with this, so the answer is 1, then the maximum remainder is 2, this is 1. If I divide by 3, the remainder is 0. So hence the possible remainders will be 0, 1 and 2. You can't have 3 over here, because if it will be 3, it will be exactly divisible by that particular number. So we'll write, since the square was required, so I'll write number can be written, numbers will be 3q plus 1 and 3q plus 2. So now let's square them. 3q square, this will be 9q square. I'll take 3 common from here, 3q square. This can be written as 3m, where m is 3q square. Whatever this value is, you take it as m, right? So that the answer, what they required is 3m, so I have proved that this is 3m. Let's take another one. It's 3q plus 1 whole square, which will be 3q square, that is a square plus b square plus 2a into b. For those who don't know the identity or who don't remember it, so it's like 9q square plus 1 plus 6q. I'll rewrite it again, 9q square plus 6q in one bracket. Let's leave the 1 outside. Then this will be 3. Let's take 3 common out from here. This will be 3q square plus 2q plus 1. Now I will rewrite it as 3m plus 1, where m is this particular bracket. Right. Now the last step, the last number is 3q plus 2 whole square. So this will be 3q whole square plus 2 whole square plus 2 into 3q into 2. This shall be 9q square plus 4 plus 12q. Right, let's rewrite it again, 9q square plus 12q. Now this is the most important step. Now this is 4. Can I write it as 3 plus 1? Of course I can. So instead of writing it 4, we will write it as 3 plus 1. So that we can take 3 common from here. So now this will be 3q square plus 4q plus 1 plus 1, which is again written as in the form of 3m plus 1, where m will be this bracket. Right. So it is very important question, and this is how you are going to solve it. First of all, you will write that by Euclid Division Lemma, any number can be written in the form of 3q plus r. Then you will write down the possible values as 0, 1 and 2, because these are the possible remainders. Then you will write the number will be 3q, that is 3q plus 0, 3q plus 1 and 3q plus 2. Now since they have asked us to put the square, that square of a number is of that form, so I will write 3q square, and whatever the value is left over here, I will take it as m. You are just substituting the values. So 3q plus 1, you have got this equation, take 3 common from here, this is 3m plus 1. And again 3q plus 2, you take this value and split it by 3 and 1, take 3 common, and this will be in the form of 3m plus 1. Right. Let's say the other question, which says that show that 6q or 6q plus 1, 6q plus 3 and 6q plus 5 are odd. 6q plus 1, 6q plus 3 and 6q plus 5 are odd. Right. So again, now this is 6. So we can write any number by Euclid's division, lemma. A number can be written as 6q plus r, where r can have possible values as 0, 1, 2, 3, 4 and 5. Right. So number can be written in the form of 6q, 6q plus 1, 6q plus 2, 6q plus 3 6q plus 4 and 6q plus 5. Right. Now, if you look it very closely, 6 into any number will be an even number. Right. Because if we write down the table of 6, it will be 6, 12, 18, 24, 30, 36 and so on. So whatever the number you are multiplying 6 with, the result is always even. So we can write it that 6q is always even. No matter what the value of q is, 6q is always even. Right. Now you know when even is added to even is added to even, the result is even. But if even is added to odd, the result is odd. 4 plus 6 is 10, whereas 4 plus 3 is 7. We'll use the same concept over here. That 6q is always even, since 0 or 6q is even, 2 is even and 4 is even. So 6q plus 2 and 6q plus 4 are even as 2 and 4 are even. Right. And since 1, 3 and 5 are odd numbers, hence 6q plus 1, 6q plus 3 and 6q plus 5 are always odd. So most of the students find it very difficult to solve such questions in which they have to prove it or they have to show a particular thing. But with practice, if you know the concepts, if you know where to place these values correctly, so it is not a very hard thing to do. Right? I hope you would have understood it. Thank you.